Hello, everyone. I'm Professor Perry. I'm the head of our chemistry department at Charleston Southern University. And I'm going to tell you about some of the majors we have to offer in our department, some of the programs we offer. And let me also tell you up front, I'd much prefer to be in a classroom talking to you face to face. But until we get back to normal operations, may this virtual session serve as a substitute. Once I get to the end of it, you'll see some of my contact information on the slide. Feel free to contact me, and when we get back to normal operations, if you have an opportunity to visit campus, I'd be happy to show you around our science facilities and talk to you in more detail about some of the programs we have to offer. But until then, let this be our substitute. Okay, so in the chemistry department, we offer two majors, the biochemistry major and the chemistry major. And then students who are interested in careers in medicine or dentistry, we also direct them to the biochemistry major. And that is not at CSU, nor at any other university do I know of, is there such a thing as a pre-medical or pre-dental major. What universities do is direct students interested in those professional schools to the major they believe best prepares them for entry into the medical schools. And at CSU, we believe that's our biochemistry major. That's going to give you very solid preparation to do well on application tests to professional schools. So of these two majors we offer, chemistry and biochemistry. I'll talk a little bit more about both of those. The chemistry major, these are students who are typically interested in more nuts and bolts of chemistry and oftentimes heading right out into the workforce after graduation, sometimes going on to graduate school. And then the biochemistry major, these are students now who are interested in understanding a lot of interest in biology, usually understanding living systems on a very fundamental basis. Now, let's be frank and note that for many students, chemistry is not their favorite topic. But if you make a connection there to biology, which more students have interest in, and if we can show students how you can explain biological processes on a very fundamental basis by understanding chemistry better, well, now you have your field of biochemistry. And that's a much more popular major amongst our students than the chemistry major is. Now, students who are interested in chemistry, these amongst majors I've seen at CSU, these are some of the most employable students immediately upon finishing their bachelor's degree. And that employment opportunities are readily available to them with the bachelor's. We have students who have graduated in recent years and employed in chemical companies right here in the Charleston area. If students want to further their training, chemistry major is going to prepare them well for graduate school. Graduate school, working on a master's or doctoral degree, those are processes where the students usually have a lot of interest in research, and that process in graduate school, particularly working on the doctoral degree, is designed to facilitate a student becoming more and more of an independent researcher. To where after obtaining the doctoral degree, one can lead a research group. Students who don't go to graduate school are oftentimes interested in employment immediately after the bachelor's degree. Well, there's a lot of testing and analysis opportunities that can be done with a chemistry major. We have some companies right here in Charleston, General Engineering Labs, GEL, it's called, O2SI, and others, that do testing of soil samples, water samples, urine samples, all sorts of samples. They're testing for different chemicals. Well, those who have a chemistry preparation are well suited for such studies. The area of forensics in South Carolina, I think pretty much every state now, the State Law Enforcement Division, SLED. Now they have a crime research labs, forensics lab, where samples are gathered from crime scenes and taken back to the lab and analyzed. Well, not all, but a lot of these testing processes involve a fundamental understanding of chemistry, being another area, forensics, that chemistry majors are well suited for. Another one I have on our slide here is synthesis. A subdiscipline of chemistry is organic chemistry. And those interested in organic chemistry are oftentimes interested in how you can take basic building blocks and synthesize those into something else. Sometimes chemicals that better the human condition. Well, that's a discipline we call organic chemistry, and it's a discipline that involves synthesis of chemicals. If we had a library consisting of all the chemicals known today, most of the chemicals in that library would be ones that have been synthesized in the laboratory. So organic chemistry, chemists engage in synthesis, another important subdiscipline of chemistry. But there are many others I don't have time to enumerate here that, depending on one's interests, a lot of other opportunities as well. Now, the biochemistry major, these students also are well equipped to seek employment right after the bachelor's degree, but many of them choose to go on to professional school. In that category, it places dental school, medical school, a pharmacy school also. Biochemistry is good preparation. All these schools, you have to take admission tests, and those admission tests cover the fundamental areas of science, physics, chemistry, biology. And a biochemistry major is going to give you excellent preparation for admission into professional schools. Like with a chemistry major, those biochemistry majors are interested in exploring research opportunities further. They often go to graduate school, work on master's or doctoral degrees, research and development with companies, biotech, pharmaceutical companies. Many opportunities here for the biochemistry major as well, depending on the student's area of interest. Now, when you're thinking about majors to pursue, a lot of different questions one probably wants to ask. Just a few of those that are listed here. And the first one you see there is simply, what do you like to do? What gives you enjoyment in life? What, when you wake up in the morning and know you're going to go work, what's going to make you happy about waking up in the morning and knowing you get to go to work doing something you like to do? What is it that you like to do? And then you want to, that's sort of your ideal, and then you want to balance that with a certain degree of practicality too, which we have in the second point here. What is the job market like? Well, what I like to do, have that on the one hand, but hopefully one can make a living at that. Well, what's the job market like for what you like to do? Can those two mesh nicely together? What skills do I need to get the job I want? And that goes along with the fourth point here as well. Will this major adequately prepare me? Will this major give me the skills for the profession? Well, what do you like to do? And what skills are you going to need to do that? Well, you want to pick a major that's going to equip you with the skills for the job you desire. In the area of medicine, for example, students who end up going to medical school. Well, you can get to medical school, a lot of different avenues can lead to medical school. But what ones are going to best prepare you for that? And that's where our biochemistry major comes in here again. That's a major is going to give you very solid preparation for the disciplines that not only are covered on the medical school admissions tests, but also are covered, at least in the basic science components, the first 2 years of medical school. And then lastly, do I have what it takes to successfully complete this major? Again, to be frank, like chemistry and biochemistry, those are not easy areas of study by any measure. They're difficult. It's not enough for students, particularly when they're first starting out, to get some grades they wish they weren't getting. Well, what type of student are you? What happens when you get a disappointing grade? You need a lot of perseverance in these fields. You know, at CSU, we provide a lot of resources for you to succeed. Professors keep numerous office hours each week, and those are for nobody else but the students. We don't hold those or gab time with fellow faculty or anything else. Those office hours we hold, those are for the students. No one but the students. We want the students using them. We also have tutoring at no charge for students. Another opportunity. Many resources we have at CSU to help students who are having difficulty, and we encourage students, don't be bashful about taking advantage of those resources you have at your disposal. This is a little bit of a comparison about some of our majors in biology and chemistry at CSU. And if I start out here in the far right with our chemistry major, you see that has of the 4 majors shown on this slide, that has the most amount of chemistry, also the least amount of biology, and actually chemistry majors don't need to take any biology at all, and a rigorous amount of mathematics. And our chemistry majors usually take so much math that they end up getting a minor in mathematics. And you see that's at least a year of physics there for the chemistry major as well. If you compare that with the biochemistry major, we still have the year of physics. A little less math for the biochem major. Considerably more biology for the biochem major versus the chemistry major right here. And then a little less chemistry for the biochem major in comparison to the chemistry major. Now, these 2 majors right here, biochemistry and biology professional emphasis, they're somewhat similar in that they have equal amounts of math requirement, somewhat similar amounts of biology and chemistry requirement, and then the biochem major you see there with the year of physics built in. And that's a big reason why we recommend the biochem major to medical school applicants, for example, because physics is a topic covered on the MCAT exam, and the chemistry major requires you to take a year of physics. And I'm not talking about the general biology here. That's a major that students interested in more wildlife, environmental biology would take. Okay, as students, you have a multitude of different options out there as far as choosing a college or university. So what's distinctive about CSU? Why choose Charleston Southern University? Well, our most significant distinction is that we're a Christian university. And certainly in the low country area of South Carolina, that's our distinction, that's our unique feature. And even somewhat in the state of, there are other Christian universities in the state of South Carolina, not a whole lot. So we're still distinctive in that sense across state. But being a Christian university, what does that mean at CSU? Well, part of our mission here, academic excellence in a Christian environment. Well, Christian environment at CSU, what's that look like? Well, all the faculty are professing Christians. Students, we accept students of any faith background or no faith background at all. All students are welcome, regardless of background. Now, that said, we are very purposeful about our own disciplines, our own areas of expertise. How do those areas of expertise relate to the gospel? That is something we purposely do in the classroom. And some of these, some disciplines that's easier to do than others. Like chemistry, for example. Well, we teach the same chemistry and from the same textbooks in almost any university in America. So that we have that in common. But what we are distinguished by is how does our particular discipline, chemistry, biochemistry, physics, whatever one study, how does that relate to the gospel? And that's a focal point. Again, that's not always easy to do, but that's something that we are very purposeful about. Professors, regardless of the discipline they're teaching, we have the green light to do that. We're encouraged to do that. I think if you ask most of the professors, why are we at CSU, it's because we get to do that. That's something we like to do. That's that thing when we wake up in the morning, put some bounce in our step. So we get to go to campus and teach our disciplines and think about how do our disciplines relate to the good news of Jesus Christ. Science and faith discussions. There's a science and faith forum that meets independently of any more formalized lecture discussions in your typical course. And these are forums where they're led by a faculty member talking about a subject matter that particular faculty member is interested in. This would be a subject area, often very contemporary one in our society that we have a topic, science says something about that topic, the gospel says something about that topic. And, oftentimes, at least these appear, occasionally to be in disagreement with one another. Well, as science and faith, these are both pursuits of truth. Their methods of doing so are different in each case. But if they're both pursuing truth and they're both understood correctly, well, we don't believe those two are in disagreement with one another when we properly understand each. So those are issues we wrestle through amongst the faculty, amongst our discussions with students. So in these science and faith forums, we want students to participate in those. They're welcome to speak up. Well, we hope they're learning from us. We also hope to be learning from them a little bit. What are their perspectives, and can they shed some light on the topic for us? And then lastly here, the Whitfield Christian Leadership Center, that's a center we have on campus that throughout the year hosts speakers. These are speakers who come in, usually very well-known speakers come in and discuss a variety of different topics, and sometimes those are topics of science. Again, very fruitful times to have these discussions about how science and the gospel, how can they inform one another. Another distinctive at Charleston Southern University, and this one's also quite noticeable to me because I've taught at some universities where students, particularly in freshman classes, sit in an auditorium amongst several hundred other students. And that's not the best of teaching environments, to make an understatement. Well, what about CSU? CSU, we put a lot of time. We allocate a lot of resources to making sure our classes stay at a much more manageable size. You're not going to have any classes here with even 100 students in them. Those don't happen. In sciences, and this is pretty standardized across the university now. Your largest course you're likely to have be about 50 students. That's the largest. Many of them will be considerably less in size. And in the science classes, the largest classroom we have holds 48 students. That's the biggest lecture room size we have in science. And even for freshman classes, some of those sections are just 24. And again, that's even for freshman classes where you have an abundance of students. And then as you progress through that freshman year and taking introductory coursework and continuing on into upper level classwork, now your class sizes are, 24 or less usually. Oftentimes they'd be a dozen, 8, 10, 12 students. Those small environments, that's very conducive to learning. And even students at CSU that would want to fall through the cracks and not be known by the professor, well, your professor is going to know you at CSU. And those personal interactions, that makes for a good learning environment. And then our labs that we have with the science classes, the largest one you'll have there in our chemistry lab, 24 students max. And again, most of these, when you get to your sophomore, junior, and senior level courses, are probably average more around a dozen students. So small class size, another distinctive about CSU in comparison to many other universities, and those small class sizes, that makes for a better learning environment. The hands-on experience here, this follows very directly from the small class sizes. Well, if you got small class sizes, you have less students competing in a given course, that's going to facilitate more hands-on exercises. Less students competing for the professor's time, for competing for equipment time. Well, you have more opportunities here to get more intimately involved in your subject matter. And these would include undergraduate research. For our science majors, we don't require, but we certainly encourage students to do at least one semester of undergraduate research. That's usually at least 3 credit hours worth. And that would be where the student works either one-on-one or 2 students to 1 faculty member in any given semester. Again, many times it's just one-on-one. Sometimes it's 2 students per faculty member. That would be where the students are going into the faculty member's research lab and participating on a research project conducted by the faculty member. State-of-the-art instrumentation. Our science building opened around fall 2004 or 5, and so it's about 15 years or so old now. It's still a very modern facility. Our instrumentation is very modern, very up to date. It's well taken care of. You don't go into a laboratory and find half the instruments in there in a state of ill. Things are working. The instrumentation we have, again, if we want to quantify it, it's certainly not the amount that a major research university would have. But for the size institution we are, around 3,500 students, we're very well equipped to carry out research projects. And some of the other things you see, dissections, you find that in some of your biology classes. And gene cloning, and PCR, and DNA fingerprinting, those are techniques of molecular biology, frequently used in biochemistry type work. Those are decades old now, but they're very important techniques used in an everyday sort of fashion now to investigate a number of research avenues in the laboratory. Very, very important techniques. Again, students are facilitated in learning these particular techniques. And then the environment, our building is about 15 years old now, but it's a building kept in very good condition. Laboratories, very well equipped. Faculty research facilities, not only do we have the teaching labs, but separate from those teaching laboratories, we have the faculty research labs. Animal holding facility, we currently don't have any animal research going on at CSU, but we do have those areas. Students interested in plants, we have botany, we have a greenhouse area on the lawn behind the science building. And then, both the first and second floors of our science facility, we have, student study areas. And particularly in the second floor, a large atrium-like lobby. That's one of the favorite places for students to study that we have on campus. That's our science building right there. Opened fall of 2005. 54,000 square feet. The general layout of it is a two-story building. General layout is have most of the biology on the first floor and most of chemistry on the second floor. And I will note also in the lawn behind this building that you can't see from the picture here, we just broke ground a couple weeks ago on an expansion of our science facilities. And that new facility is going to house some additional biology and chemistry space. It's also going to house a new engineering program, four-year engineering program that's coming online on campus. So it's actually in effect now for incoming freshmen in the engineering program, but that facility will be opening in about 18 months. This is a picture of our chemical instrumentation laboratory on the second floor. A lot of the instruments there, we have chromatographs, spectrophotometers, instruments that are used in analyzing molecules, not only in a qualitative sense, but also in a quantitative sense. Those things you see hanging from the ceiling, we call those are snorkels, is to remove any volatile gases from the laboratory and take those outside. Students who working on a research project with a faculty member oftentimes are involved in using instrumentation in this laboratory. And then in chemistry, we have a course that's simply called instrumentation that teaches the theory and practice behind each of the many instruments that we see there. And then, one of our other distinctives, being a university that's not too large in size, again around 3,500 students, is that we participate in Division I athletics. So students that have talent in athletic areas, there's opportunity to participate in many different men's and women's sports here. And maybe you don't have a lot of athletic talent, but you like being a spectator. Like I do. Well, a lot of opportunities to go and watch our athletes, and with your CSU ID, that's of no charge to you. And then a little bit about the city we're located in. We're on the CSU's campus. Those of you who might not be familiar with the area, we're on the outskirts of Charleston. We may be, I'm sure our exact distance, maybe about 15 miles or so from downtown Charleston. But Charleston, City of Charleston annually ranks as one of America's most friendly cities. It ranks very high on a yearly basis and favorite destination for international travelers. As someone who was born and grew up in Ohio. I'm one of those Yankees that has migrated to the South, but I'm very happy today to call Charleston my home. It's a beautiful city. The coastal areas of South Carolina in general has done a pretty nice job of taking care of their environment. Our coastal areas are beautiful. A lot of opportunity to get outside and participate in a lot of activities, a lot of cultural events in the city of Charleston. So CSU is right in the center of a thriving city that's got a lot of history, a lot of culture, a lot of great places to get outside and enjoy nature. In my last few minutes here, I just want to say a few things about your preparation in coming to the university. Now, whenever students get to CSU as professors, we try to meet you right where you are and do the best we can of preparing you for your goals, for the job you're seeking. Well, the flip side of that is that we hope before you get to CSU that you are doing the best you can to prepare yourself. And the college board that administers the SAT exam, they've been doing this for years and years, and they have mountains of data on this. You know, they've looked to see what students, when they get to the university, the ones that are succeeding, what have they been doing in high school? And success here, you know, that can be an arbitrary, what we define as success can be quite arbitrary. But the College Board defines that here as a student that when they get to the university in their freshman year, they get a B or better average their freshman year, because the College Board says getting that is very important as a predictor in doing well your remaining years, in graduating in 4 years from college, for example, and getting a job afterwards. Well, and the students that are getting that B average or better their first year of college, that correlates with getting a SAT score in today's SAT about 11 to 20 or better. So that's sort of that SAT target there, at least 1120. That is, if you're getting that, it's a pretty good predictor for doing well once you get to college. Well, working backwards here, students to get that 1120 or better, what have they been doing in high school? And this slide might be a little difficult to read there for you, so I'll point out some of these. First thing most of these students are doing is taking high-level math, whether it's trigonometry, pre-calculus, or calculus. Whatever the highest math courses your high school has available, take those. If you want to major in the sciences in college, take those higher level math courses. Because we could build a pyramid where we would have mathematics on the bottom and maybe physics above that, and then chemistry and biology and social sciences as we get more to the peak of our pyramid. And that thing you have down at the bottom there, mathematics, that's the foundation for all of our sciences. And that is, if you're in math, you're doing well in that area, that's probably a pretty good sign that regardless of what discipline of science you choose, you probably have a pretty good odds of doing well. These students are also completing a core curriculum in high school. That would be 4 years of English, at least 3 years of science, 3 years of math, and so forth. They're also taking AP or honors courses. Again, if your high school offers those, and if you have the prerequisites to take them, take those courses. I mean, if you take an AP course, for example, and take the AP exam at the end of it, and you score high enough on that AP exam, CSU and pretty much every other university will allow you to, in effect, test out of many freshman level courses. Taking high-level math, taking AP courses, we know those aren't easy things to do. And on one hand, in high school, you're trying to manage your GPA, get a good GPA because you're applying for scholarships, and we know that, we appreciate that. But as far as professors go, we want you to take those difficult courses in high school, even if your GPA gets banged up a little bit. And that's because that's telling us that you might have not gotten the score in that class that you would have liked to have gotten, but you took something difficult there. And that's telling us that you're going to be more amply prepared for your college level coursework. So don't shy away from those difficult courses at your high school. As professors, we want you taking those because those are going to better prepare you for the college experience. One other thing to note here, rank in the top 10% of their high school class. Well, that's not a very good predictor of success in college. And that tells us that there's a lot of variability in our high schools. Ranking in the top 10% of one high school, well, that may really be outstanding. Ranking the top 10% of another high school, well, if that high school is not a strong high school overall, that may not hold a lot of significance. So don't have any hang-ups about where you rank in your graduating class. Some of these other things, your math preparation, taking AP or honors courses, those are more significant when it comes to doing well in college. So those are some things, if you have time yet in high school, that you can be doing to give us a better material to work with once you get to the university. We like to see you do those things. And then when you get to the university, you're in a better prepared state, and we're going to be able to hopefully propel you forward to higher levels if you come in at a higher level. I think my time is pretty much expired here. If you're thinking about some of these things and you have any questions that come up, you have my email address on the bottom of the slide there. Feel free to send me an email. And like I said at the onset, if you have opportunity to visit the Charleston area, visit CSU, I'm more than happy to show you around our science facilities and talk with you in more detail about your career plans and at least how our chemistry and biochemistry majors might apply to those. So thank you very much for listening. Goodbye.